All right, good morning, guys. We've got our 2.6 notes. We have a quiz on Wednesday. This is day one of our 2.6 notes. And what we're going to be working with today are congruent angles for the most part. So we should define what congruence means before we do anything else. And what it means to be congruent is that we have two figures, in this case, angles, that have an equal measure. So if I said angle 2 is congruent to angle 4, then the measure of 2 is equal to the measure of 4. So they have equal measures. Here would be an example of two congruent angles. They have the same measure. They're both 137 degrees. So let's look at one of our 5 congruence theorems. We've got the right angles congruence theorem, which just says that all right angles are congruent. And remember, congruent means that they have the same measure. If that's 90, and that's 90, and that's 90, well then, those have the same measure. By definition, they are congruent. And let's look at some congruent complements and congruent supplements. So congruent complements says that if two angles are complementary to the same angle, then they must be congruent. So let's look at a concrete example here. If I've got two angles, let's say this is angle 1 and angle 2. And complementary means that they add to 90. So if I had, for example, angle 1 plus 70 equals 90, so if angle 1 is complementary to 70, and the same thing for angle 2, well, we could find what angle 1 and angle 2 are. We could just subtract from 90 and get 20 for both of these. And then it becomes pretty obvious that these are congruent angles. They have the same measure because they're both 20 degrees. Or another example, if 1 is complementary to 20, then 1 must be 70 degrees. And if 2 is complementary to 20, then 2 must be 70 degrees. So these are congruent because they are complements of congruent angles. They are congruent complements. Same idea works with supplements. So let's look at one example of each. For my congruent complements theorem up top here, let's look at two angles that are both complementary to 50. So y is complementary to 50 and x is complementary to 50. They both add to 90 degrees. So y is angle ABD, and x, I would have to follow the same pattern. That would be, this is supposed to be a G out here, GFN. And then, of course, I could say that, I won't here, but I could say that angles DBC and EFN are not complementary, they are congruent as well by the definition of congruence. They have equal measures. And if I found these angles, these would both be 40. So that's a nice way to check. Just do some algebra, and you'll see that these are both 40. Let's try some congruent supplements theorem. Now I've got angle B here and angle W there. And if these are supplementary, they add to 180. So I could find out by subtracting from 180 degrees that this is 115 degrees. And that W is also 115 degrees. So because they are supplementary to 65, both of them, then they must be equal to each other. So angle CEH must be congruent or equal to, let's see, CEH FAD, angle FAD. And of course, we could do the other pair of angles as well. I could say angle BEH is congruent to angle DAG by the definition of congruence because they're given as 65. So that's another possibility. I'm going to skip this proof here for right now. Not super necessary for our lesson today. The most important part is right here. We've got two more postulates. We have a linear pair postulate. Remember, that's a pair of angles that form a line. And our linear pair postulate says that two angles that form a linear pair are supplementary. They add to 180. So if one of these angles is 37, this forms a linear pair, then 180 must be the sum of 1 and 37. So this would have to be 180 minus 37 would be 143. And same idea on the other one. 136 and 1 form a line, so these add up to 180. If I take 180 minus 136, I would get 44 degrees. And you could do the same thing on the other side to find this missing angle. And then you could take another linear pair, once you found that, to find this missing angle. So lots of possibilities to use this theorem. This one provides an opportunity for a shortcut, but only if you know the vertical angles congruence theorem. And that states that vertical angles are congruent. So let's talk about vertical angles. Those are my angles that form, two V's or an X. So there's one V, there's the other one, or there's an X there. They are across from each other, and they are the same measure. So 28 degrees must be congruent to angle 2, 28 and angle 2, and then angle 1 and angle 3 are going to be congruent as well. Then if 28 and 2 are congruent, this must be 28 degrees. And now we can use our linear pair postulate to find the measure of angle 1. So if the measure of angle 2 is 28 degrees, I could take 180 minus 28, because remember, the linear pairs are supplementary, and this would be 152 degrees. And then I could use the same logic to find angle 3 at 152 degrees. And our last problem here for today, this is what your homework looks like. This is what I want to see. Now, we're not doing really big formal proofs. These are just informal. So the first thing I want you to tell me is, what kind of angles do you see? So 2r plus 3 and 89 are what? If they're across from each other, those would be vertical angles. And we could say that's given in the diagram. And now that we know they're vertical angles, then what do I know about vertical angles? Well, I know they're congruent, so 2r plus 3 is congruent to 89 by the vertical angles congruence theorem. Now I'm going to use another definition. So we used our first definition, that got us a second definition, so let's use that second one. What does it mean to be congruent? Well, that means that 2r plus 3 equals 89. by the definition of congruence. Remember, congruence means that two things are equal. And then we're just going to use our properties of equality. So 2r equals 86 by the subtraction property of equality. And of course, I'm just abbreviating. I would like you to see all that stuff written out. And 5r is 43 by the division property of equality. And that's all we need for today. Send me an email or drop into my office hours if you have any questions. Otherwise, we've got a quiz Wednesday, and I will see you in